Hello there. We'll be getting started with tonight's talk in just a minute. Doing a quick sound check before we start. Sounds good. Let's begin. So, last Monday, we kind of did a little recap of some web stuff we touched upon way back at the early fall, start of the fall semester. And on Monday, we then kind of looked at some client-side stuff like XSS, cross-site scripting, and CSRF, client-side request forgery. It's a typo. um, but yes, overall, we've been working on just kind of talking about some that's client-side stuff, some of the basic. So today we're going to be looking at a little more advanced stuff and a little more server-side stuff. So, and just as a refresher here, the web category kind of covers two big areas: client-side stuff and server-side stuff. So, client-side, remember, it's like your browser, and generally people who are asking web servers to do things, while server-side is trying to exploit the servers that's actually providing these services, unsurprisingly. And as a kind of matter of opinion, the server-side stuff tends to be a little more kind of varied. Client-side is a lot of just making the browser misbehave and occasionally breaking out of the JavaScript sandbox. But server-side is a whole just hornet's nest of different ideas and all kinds of things glued together. If you ever looked at like the architecture map for like any big web application, it's gigantic amount of stuff. So yeah, you'll see a lot going on there. And we'll just be kind of having a look at some of the fundamental stuff and some, a few interesting things here. So yeah, we're going to be looking at these different topics here: path traversal, SSRF, SQLi, and filter evasion. And if you don't know what those acronyms mean, well, hold tight. So first up, path traversal. So we're going to have this great website here called coolphotos.biz. Cool Photos is a photo gallery. It lets you, upload photos, put them in the gallery, share them with other people. So, for example, Alice here might have a gallery called Pets, and that gallery is, so you go to coolphotos.biz/Alice, and then you give it a parameter for the gallery, and we're going to look at pets. Now, since we're an agile startup, we're just going to put this up in the file system. We don't need the fancy database for these images. So our server might look like this. We have like data galleries, Alice, pets, dog.jpg, or cats.jpg, and so forth. So to get someone's gallery, all we have to do is read their directory and see what files are in there. And so it's a lot like we just said, ls, data galleries like Alice, and then say pets. Now, this seems secure. We're going to ask, okay, give me all the files in this directory. It's not like I can just ask for the list of user accounts on the server or something, or leak all the private records. It's just asking for a folder. Well, there's a problem here. So if I ask for the dog gallery, it's going to look like this. We'll say, okay, data gallery is Alice dog. And pretty simple. Nothing crazy happened here. What if I ask for the dot gallery? Well, that's going to translate to this, which is, /data/gallery/Alice/dot. And as you might know, dot just means the current directory or, same place. So that just translates to the exact, to just Alice. So this would give the server would respond with a whole pile of things, one for each gallery. And we might ask for the dot gallery. And as you know, dot means up one directory. So this will actually take us up a level to the galleries. And if I ask for the triple dot slash Etsy password gallery, well, that's going to take us all the way up to the root, because we're going to go dot. And so that's going to take us all the way back to the root directory. And from there, we can ask for Etsy password. So that's a problem. And the problem is path traversal. So we've broken out of the web, which is kind of like the folder in which all the web stuff is supposed to be living. And depending on what the server does with this, we leak all kinds of different things. So if the server just sends you back a list of names to like like images to load, it'll give you file names because in that case, like it'll ask us to ask for images that don't exist that we cannot possibly access. But if the server actually uses the files directly in the response, then you could leak entire files. So if you had this like classic, CGI script that just that renders, orders, returns a whole page. If you tell it to return itself, then you've leaked source. And so this is a handy way to kind of peek at what's going on the server and to leak out source files, which is very handy for doing further analysis. Now, even worse, the server might not be qualifying its paths, as in it might just be, saying, oh, just open foo.txt instead of building up an absolute path. In that case, you can just give an absolute path and it'll take you right there. So if it was just using its current working directory to look for the file, then putting a slash in front will send you all the way back to the root and you're good. Steal password file, go looking around in logs, see what permissions they have, that kind of thing. And one thing to note, if you have excessive numbers of dots, it's completely fine. So that'll come up again later, actually. So this is pretty easy to prevent. Like PHP, for example, can very specifically set like what the base directory is, and it will not open files outside of that base directory. You can filter out anything with .dot in it. Now, this could cause problems if you have file names .dot in it or something, but that should work, hopefully. And you can change the root directory of a process to completely lock it down inside there. There are kind of ways to escape a true jail, but generally not just by asking for files. So that'll be pretty safe. So we made the server open files that we shouldn't be opening, but what if we made it just do anything that it shouldn't be doing? So just like there's CSRF, which is cross-site request forgery, which is where you trick a client into opening making a request they didn't mean to make, like transferring all of Alice's money to Bob. There's server-side request forgery, where we make the server do something it shouldn't be. So let's say coolphotos.biz has a new killer feature. Our full-stack blockchain developer has hammered this out over a weekend. Webhooks. So what this will do is every time you post an image, it'll go notify you. So it can you can have an integration with Twitter to tweet your new image, that kind of thing. So this server is going to get a certain URL and also handily show you the response because you're debugging your Twitter integration. You probably want to see what kind of thing your server is doing just in case there's an error. So yeah, we got webhooks. Now, public-facing servers often have non-public access. So, for example, you might have a database that you're allowed to talk to. You might have metadata from your cloud host, from AWS or Azure, whatever you're on. You also might have other just private APIs or public ones that the server specifically has credentials for. So normally this information is completely out of reach, especially anything that's on a private internet. Like you cannot reach it from the public internet. There is no path to it. But what if we ask the server really nicely to, just do it for us? So I'm going to tell the server, yeah, I have a webhook at 169.254, 169.254. And you might recognize that as a linked local address, which means it's kind of one that only makes sense in a very local space. And it's going to go to /latest/metadata. And the astute among you might recognize this as AWS's kind of metadata endpoint. So then when I post a cat photo, the server makes the request, gets the metadata, and shows it to us. Whoops. So that's how SSRF happens, when an attacker can make partially or fully control where the server goes to make a request. And this is the most obvious and kind of trivial version, like webhooks, where you literally tell them, "Here's where you should go. Just go read something from there and come back to." But there are weirder things like XXE SSRF. XXE is part of the infinitely cursed family of XML related exploits. Every time I learn about a new XML thing, my heart sinks further. Particularly XXE is whenever you basically make the server load an XML thing that it probably didn't want to. And this can often be things like files, but it could also be remote resources. And the interesting bit is that they'll actually be included into the resulting XML document, which the server might then give back to you. So you can suddenly start leaking files and leaking other things out. It's pretty gross, but it is pretty cool. And bad parsing too, which actually we'll touch on in just a minute. But the thing there is, what if the server thinks you're only partially controlling where it's going, but it misunderstands the input and you wind up fully controlling it. But actually, I'll skip ahead because this is exactly what that would be, and this is a fun little talk by Orange Zai. This input is parsed as 3 different IP addresses by 4 different libraries. So you can wind up getting these weird polyglot URLs that go different places, and so that can wind up defeating filtering. Because what if they say, okay, well, we'll just deny access to private IP addresses, and maybe you can't go to local hosts, that kind of thing. But maybe the filter sees this, but the server does this. You have trouble. And you can also try to deny everything that is not known to be good. We only have these APIs. Like, well, okay, we'll just only permit those things. Now, of course, this might contradict your agile startups move fast and break things methodology. So maybe you won't do that, and then maybe you get burned by it. And even ignoring that, there can be some other really weird issues. Like, what if the thing you're sending to redirects the server and sends it somewhere else, and that somewhere else is evil? This could be a problem for webhooks, for example, as this one HackerOne bounty suggested. That was a $700 bounty there. It's a fun little one. So that's SSRF, making the server go somewhere it should. But now let's make it do weird things to databases. So our photo gallery needs a search bar. We need a way to, in an agile web manner, search for dog photos or whatever. So say we have the metadata in a real database. So I can just query for dog and get a list of dog photos. Or maybe I'll search for dog, quote, semicolon, drop table images, semicolon, dash, dash, and the entire database is gone. Oops. So this is SQL injection, where SQL stands for Structured Query Language. And SQL or SQL, or Squirrel as I've heard it pronounced, really strange, is the kind of the standard way you talk to databases. You connect to them, you query them, you update them, you delete everything from them, that kind of thing. And naturally, this is injection because we are putting weird things into an existing query. And this happens because we mixed code and data. This was supposed to be data, but then over here we got all this code, and they're getting conflated. So how did this happen? Well, the most obvious way to build a query is to do something like this. So over here, we're going to say, select IDs from our images table where the name equals, and then we open a quote mark, put the query in there, and then put a closing quote. So if the user types something that isn't evil, like dog, this will just turn into a healthy query. So that would just be dog in there. But if our input was this weird dog drop table images thing, well, this happens. The single quote closes the string, a semicolon ends the query, and then a second query begins where you drop table images. And then we just comment out the rest to make sure that whatever else is in the original query doesn't matter anymore. So most injection techniques like XSS and SQLi, among others, like command injection for, like when you shell out to a program, follow a very similar pattern. So you begin by escaping from the data, you perform some evil actions, and then you clean up. So you generally begin by escaping from some piece of data, like usually a string, but it doesn't have to be. So like an SSS, we don't really have to do anything there because typically the evil input is being placed directly into a safe place in the HTML, like, it's putting into a div. So it's already a good spot. But it might, if you're getting injected into a tag, for example, you might have to close up that tag first. And then SQLi, as shown, you typically want to need to close rotation. But if you're on a number, for example, then you're already free. So at this point, we're out of the data. We are now writing code. So we performed our evil actions, like inserting a script tag that pops up an annoying BonziBuddy installer, or whatever you're happening to do. And SQLi will typically, add a new query, or maybe it'll add data onto an existing query, or it'll just try to profile a database. And this is where the actual interesting stuff happens. And then finally, we got to clean up again. XSS, we might have been in the middle of a tag, so we should probably recreate it again just so that the entire document is nice and clean. But HTML is famously generally leniently parsed by browsers because, as we mentioned on Monday, browsers are desperate to make the website just work. If the browser doesn't make websites just work, people won't use the browser. So they have incredibly lenient rules for what is valid. And so you might not have to do that at all. Well, SQL is generally very strict. And typically the solution is to just comment out the rest of the query. And that means that at the end, your query will be completely valid. So there's a decent bit of nuance to SQLi, and there's a whole lot to talk about. So sometimes, for example, you can't see the result of the query, but you want to get data out. And we call this blind SQLi, or SQL injection. A handy trick is you can often infer things from timing. For example, you can make the database sleep for a second if the first bit of a password is 1, and then use that to enumerate every single bit of the password. Or you can, sometimes you can even make databases run code, run scripts, which is absolutely terrifying. But in that case, you can make them reach out and talk to you. And sometimes you need to kind of sneak extra data in. Maybe this is a search that is pulling out a list of usernames, and it will only work right if there's only a single column. What you can do is use a union to just kind of glue together two separate queries. And so maybe you'll get a list of users and then a list of their credit card numbers back to back. So there is a lot more to talk about in the SQLi area, and we're probably going to do a talk on this in the spring, so keep an eye out for that. So how do we stop SQL injection? Well, the most obvious thing, I guess, is, filter. Just don't let people type quotes. Don't let people type select. Well, spoilers, that's often a losing battle, and we'll find out why in a couple minutes. And instead of trying to fight that battle, we should just do the correct thing. And the correct thing is to separate code from data. So most SQL libraries, at least good ones, will come with ways to make what are called prepared statements. And these basically mean that you set up a whole query, you parse it, you find the meaning of the query, except for the exact values you're using, and you store that. Then you just insert the values into it when they're available and execute the query. So this completely separates the parsing from the filling of the values, and thus makes it safe. And then this slide says the exact same thing here. So you're protecting yourself against this by never using user input to actually structure the query, and that keeps you safe. These are mostly bulletproof, except for when, say, a specific PHP library decides that if the server does not support prepared statements, that it will just fall back to string concatenation. And, oh no, very sad. So, to kind of wrap things up here, we're going to have a quick peek at how to get around filters, because a common theme we've seen here is that filtering is a solution to all these different things. Like path traversal, if we filter out double dot, like that's pretty safe. SSRF, if we say block private address spaces or only allow certain things, well, that's good. And then SQLi, like just don't let people type footmarks. But unfortunately, filtering is a minefield. So filters tend to be very brittle. The goal is to only reject malicious input. And so, for example, you can immediately run into problems when someone is named, O'Connell, and the single quote in their username sets off the firewall. Not going to be happy. So you have to be careful to not do that. And furthermore, there's a lot of ways to express the same idea usually, and this is typically how filters get evaded. You don't change attacks completely. You just change it a little so it doesn't quite look the same anymore. So, for example, I can get to Etsy password in several different ways here, and so I can just go directly, or I can kind of backtrack, or I can go way up and then back down. And furthermore, different systems will interpret things differently. Like that thing earlier we saw with the weird parsing of addresses. Different systems, you might have a Python system, you might have two different JavaScript libraries, you might have something written in Fortran, I don't know what you're doing. But each one of those will interpret things differently. And that also extends to the browser. It will interpret things differently. Classically, like you can put like tabs and spaces and other weird things in the middle of your HTML tags, and they'll just roll with it. They're again, the browsers are totally desperate to make the thing just work, which can lead to the browser doing very strange things. So path traversal is reasonably simple to filter, actually. Just don't let people type this, the double dot slash. But we do have options. So, for example, we can escape dot dot slash as with the these URL encoded values, and the filter might see those, while the backend might see the decoded version, and suddenly we have once again that discontinuity. Once these two different systems see different things, they act differently. Bad stuff happens. For SSRF, there are a lot of ways to write localhost. You might know that 127.0.0.1, there's no place like home, etc. But that entire /8, so anything beginning at 127 is actually going to be looped back. So you can go to any other address in there. You can go to localhost with all like sarcastic caps. That works. And another thing you might not know is that you can use hex for an IP address, or you can just use an integer. This is just a base 10 number here. I just converted this from octal to, decimal or octet notation decimal, and there we go. So all those are localhost. There's also a lot of interesting URL schemes we can use. You might know, okay, HTTP, FTP, those are pretty common, but there's also like LDAP, file, Gopher. That's been dead for decades, but kind of it still works. And PHP especially has some really weird things, like SSH as a protocol. It's designed to make it so it's nice and easy to access things at like the files. But this also means that you can start making servers like do all kinds of stuff. And that's again a whole fun talk on its own right. It's all the different things that can have PHP filters. And then SQLi. So sometimes you don't even need quotes, even if the filter is blocking them. So for example, if you're injecting into a numeric field, you're querying for somebody by user ID, well, that's not a string. It's just a number. So you just type space and you're good. You are now writing more code. And sometimes you can do some weird stuff with text encoding. So, and this is especially important for older databases that are like, they only understand ASCII or something gross like that. So that this weird smart quote here is not the same thing as this single quote, but it might get converted for us. And similarly, I've seen some really crazy ones where you use a 2-byte Unicode character, and the filter interprets that correctly as like a Chinese character or something like that. But then the server thinks it's ASCII. The server sees two separate characters, and it sees some random symbol and then a single quote. We have broken out of the string. So you can, again, it's like this is the running theme here is that unless every single thing in your system is on the exact same page, you can get these discontinuities that screw things up. And keyword filtering can get messed up. Like, maybe you aren't mean. You just delete. You see the word select, you delete it. Well, this string here, you delete select from this, you make another select, and there you go. And then you can also have things like, sarcastic case again, or just inject a null byte in there somewhere. Some things will end at null bytes, some things won't. And that's been useful for like tricking PHP into thinking you're uploading a PNG when it's really an executable file. You use that null byte, it stops. Other things don't stop. And so that's kind of a classic way to kind of break those filters. So filtering is often performed by WAFs, or web application firewalls. So these aren't quite like a normal firewall. They're not like there to manage individual connections. What they are there for is to detect and mitigate common attacks. So your WAF, for example, might look for obvious signs of probing for SQL injection and block you or log it or something. Now, these aren't necessarily going to always work. And it's kind of a hint that maybe the thing behind them isn't too well designed. So they're a very common sight. And finding out what is in the way can be an art in itself. So you're kind of like probing to see, well, what pisses off the WAF? What doesn't? And this thing linked here, which you just search OWASP WAF profiling, you'll find that. Is a nice little presentation about that, albeit with some really stale memes in it. Seems about right for OWASP, I think. But you kind of imagine it's a lot like trying to like identify something in a black box situation where you make inputs, you see outputs, and based on exactly how the server responds to you, you can kind of figure out exactly what you're dealing with. So I think the moral of the story here is that filtering helps, but it is not going to save you. Ultimately, you just need to stop mixing code and data, and that will keep you safe. Conversely, if you're attacking these systems, which is probably what you're more interested in here, you want to look out for any situations where there might be this mixing of code and data and abuse that. Whether it's to, do path traversal, whether it's to make a request to a bogus location, or whether it's to totally hijack a query. You want to look for that. So just some more things to look at on your own time. OWASP has some good resources on filter evasion, some nice kind of community wikis, some good old, what kind of stodgy PDFs for business types, also the whole gamut. And if you want to try some of these things out for yourself, rootme.org has some nice web challenges. I was actually planning originally to do some of them, but they really don't like you sharing solutions. So go ahead and try solving some of them for yourself. I think some stuff we talked about today will be quite relevant. But that's the end for today. So as usual, I invite you to check us out in Slack, rpisec.slack.com. Join us there with your RPI email to see what's coming up next. Next week, we are planning to have some fun talks on embedded hardware. So this is like low power devices like your router, that kind of thing. And like, what do you do to exploit those, and what kinds of flaws are built into them typically? Definitely on Friday, maybe on Monday. We haven't nailed that down yet, but you check out our Slack, we'll let you know. That's about it. So thanks for coming by or watching later, however you're here, and hope you have a good one.